Yeah, hello everyone. Welcome to YourPedia Education. So let's start the class. So basically, as you know, YourPedia is already providing a book for BEL exam. That is very good book. It is having around 2,500 questions for that BEL exam, right? So you can go for that one. And as you know, you are having only 1 days for your exam, right? Day after tomorrow you will have the exam. So I can say only one thing, that you have to revise only your concepts, and in the meantime what you have to do, you have to solve as much as question as possible, because this is the exam where you know not need to practice, you not need to go in depth of each concept. You have to solve as much as question so that your concepts is revised, right? Don't solve the gate questions, right, which is the past gate questions. You can solve the questions which we already provided in this book. Okay, good afternoon, GV Kumar, right? Good afternoon, right? Okay, one more thing, I will tell you that after the exam we will going to do a live session for you, and you can join our free group in which you can share your questions, and we will do the analysis of the paper, right? The which type of question is asked, and some student put the questions there, and we will analyze that answers, and we can predict how much is the cutoff. The paper level is hard or medium or easy. Accordingly you can predict that what will be the cutoff for that exam. And for that one, what you have to do, you have to go in the free group, right? You can we will provide the link of free group in this, you can say the below section. You can join that free group, from where you will get you can put your questions there, and we will analyze after the exam, right? That's it. Main thing what you have to do, this is the right, this is mostly, this session is having 100 questions. That is very good questions, and I'm coming here come with the questions which are from all the subjects, and we will do the detailed analysis of each question. This is our first question. Try to solve, everyone, right? I think most of the students are from the previous sessions, right? Most of you are attending the previous session also, right? Yes, good afternoon. Good afternoon, Madhu. Madhu already attended the last session. She gave the answers for the questions last time also. Right. This time I'm coming with the all subjects questions. Around 100 questions are there, right? Okay, Zoom. Right. Is it visible now? Srinidhi, it is visible now? Right. Double. In a pure capacitive circuit, the instantaneous power curve is sinusoidal of the frequency of V and I. Tell me what is the answer for this question. Geetha says D, right. Elon Musk. Who is Elon Musk? Elon Musk says D double. Okay. Deepika says it is D. See, for electrical students, this is similar questions, but not communication. But all the subjects I cover here, other than power electronics and power system and machine. But all the other subjects are for electrical also equally important. You can attend this session where you got the communication and communication and EDC question. You can left that, but rest of the questions are also for you, for the electrical students, right? So don't wait for electrical session. It is for all, both electrical and electronics. Srinidhi says B. B means half. Okay, let's do. In a pure capacitive circuit, the instantaneous power curve of a sinusoidal of a frequency V and I. See, basically, when you go for the power curve means what? When you draw the curve for current and voltage, what is happen here? The one second. The curve. Let us take, this is your voltage curve. Voltage curve is like this. Then current curve is 90-degree out of phase. Like where your, yes, where your voltage is maximum, current is that time minimum. So when you do the power, power means what? Power means what? This is positive, this is no positive. When you multiply them, it will be look like this one. What is happening here? From 0 to, let's take this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. What you are observing here, from pi by 2 to pi, the voltage value is positive, current value is negative. When we multiply them together, we are getting a negative value. So the curve is like this. So what you are observing, if you go for the period of the voltage, it is 2 pi. If you go for the period for the current, it is 2 pi. Then how much is the period of power? That is half of that one. That is of pi. So if you go for the frequency, if your current frequency is 1 upon 2 pi, if your voltage frequency is 1 upon 2 pi, then power frequency is 1 upon pi. Understood everyone? So it means what? The power frequency is double of current frequency and voltage frequency. Remember that thing. Understood everyone? So you can draw the graph, you can easily understand that thing. So or either you can directly remember that thing. If you are going for capacitive or inductive circuit, in that capacitive and inductive circuit, the power frequency is just double of the voltage frequency as well as the current frequency. Understood everyone? That is for both capacitive as well as the inductive circuit. So answer will be D. Yes, it is also a good question. Do it everyone. Srinidhi 0. Geetha 0. Power. Okay. D 0 0 0 0 0 0 0. Very good. So basically, everyone, your answer is correct, 0. Basically, when you go for the ideal voltage source, so ideal voltage source is like this. So basically, here is the resistance. Generally, if I talk about the generally voltage source, so here is the resistance of that source, that is RS resistance, internal resistance. This is your source voltage here. So if you want to make it ideal, what is the condition? That source should be available at its terminal. These are the terminals which are available for that source outside for you. You can connect your device on these two terminals. So basically, if you want to get a good result or ideal case, so what should be the voltage at VAB should be equals to VS. But if your RS is there, that voltage will be less. So what should I do? I have to make this RS value 0 so that you will get the AB voltage equals to VS. So what will be the answer? 0. Understood everyone? I think everyone understood this thing. Yes. Do it. Yeah. Wakanda, what do you want? Hello. Hello, sir. Hello, Wakanda. Yes, try to do it. Srinidhi says B. Magnetic flux divided by area. Where this is magnetic flux density. Wakanda B, yeah, right. Harsh B, right, correct. So answer is B, because what he says, magnetic flux density. Magnetic flux density means what? Deepika B, right? Deepika B is correct. B is correct answer. So basically, when you go for magnetic flux density, that will be represented by B. and B is written is as flux per unit area. Flux per unit area is known as magnetic flux density, right? आंसर दिख रहा है? अच्छा, बी नीचे से तो मत देखो भाई अगर दिख रहा है तो, ठीक है। सुबह में अगर आंसर दिख रहा है ना भाई, नीचे नहीं देख रहा आपने, आपने क्वेश्चन पे फोकस करना है, ठीक है। आंसर क्या आएगा? बी आएगा। हाँ, ये फॉर्मूला होता है इसका, और बी की वैल्यू किसके इक्वल होती है? म्यू आर म्यू नोट इंटू एच। म्यू नोट की वैल्यू क्या होती है? 4.2 × 10⁻⁻⁷। चलो नेक्स्ट क्वेश्चन की तरफ चलते हैं। राइट, डू इट। सौरभ इसको करो, सॉरी सौरभ नहीं, शुभम है ये, सौरभ कुमार। यार पीडीएफ शेयर होती है भाई, पीडीएफ हम लोग शेयर करते हैं, राइट? दैट विल बी शेयर ऑन ग्रुप्स एंड दैट विल बी अवेलेबल ऑन पैनल. You can download that thing from the panel. I think ACL classes are going on. You can contact to Gurvinder sir. They will guide you that how you can join that ECL classes. ECIL classes, right? Do it. Okay. Everyone giving the answer B, B, B. Some answers are C. Priyadarshini says C. Deepika says C. C. Some student says B. Usman says B. See, one thing, write the answer only once. Don't put it again and again, right, Usman? Pawan says C. A. Kumar says A. Okay, let's read this. What he says: a ideal constant current source is connected in series with an ideal constant voltage source. So what he says, you are having a voltage source here and a current source, ideal current source in series with this voltage source, right everyone? Oh, C is constant power source. See, basically when you connect a voltage source in the series of a current source, what happened to this circuit? See, in the series current remains same or not? As you know that in the series the current will remain same, so it means throughout this circuit the current is always remain I. As your voltage is 2 volt, 3 volt, 4 volt, 5 volt, is the current value depend on this voltage value or not? The current through this circuit is independent of this voltage. So what we can say, that you can replace this complete circuit with a single current source, because this current source is a constant current that will does not depend on the value of this voltage source. Understood? So answer will be B, not C, not A. B will be the correct answer. Abhishek, yeah, your answer is correct. That is B. Yes, yes. Wakanda, you can contact to Gurvinder sir. He will tell you. Their classes are going on for ECIL. Right? Understood everyone? So basically this is the concept. When you are having a voltage source and current source in series, if you are having voltage source and current source in series, then you can replace that single current source. One more thing you have to know. Basically, if you are having a voltage source, in parallel with current source like this, right? This is the voltage source, this is current source. You can replace that with a single voltage source, because here voltage will be same. The voltage will not depend on this current, so it will be replaced by a single voltage source. Got it or not? In parallel, if you connect the voltage and current sources, that will be replaced by a single voltage source. Understood? I think everyone understood this thing. Yes. Tell me the answer. Saurabh, what you want to understand, Saurabh Kumar? Voltage will be okay. You are giving the answer for that question, right? Series current parallel voltage. Yeah, right, Saurabh. You are correct. Okay. B. Everyone giving the answer B. Yes, everyone know this question. That is, the capacitor will store the energy in the form of electric field, and inductor store the energy in the form of magnetic field. So answer will be electric field. Correct. Yes. Do this. Yes, sir. Half CV square is the formula for uh, the energy stored in the capacitor, but that energy will be stored in the form of electric field inside the capacitor. Okay. In this one, D. Yes. The correct answer is D. Everyone, the correct answer is D. Basically, why this correct answer is D? Whenever you go for complete response of any circuit, that will be the sum of, this is the question from control system, that is the sum of natural response plus force response. Force response of the system is that will be generated due to the input, and natural response that will be generated due to the initial condition, right? This is the natural response which is generated due to the initial condition of system naturally, right? Force response means when you apply the input to that system, the response generated by that system is known as force response. Understood? So that's why total response is the sum of natural response as well as the force response. Next question. In the circuit, the voltage V1 and V2 will be, solve it. You have to find the V1 and V2 voltage in this circuit. A answer. Elon Musk says A. Asutosh Kumar A. Asutosh only put one answers because it will spam the chat, right? I will not see the answers for other students. Madhu B. Right, Madhu. Madhu answers is correct. Everyone giving the wrong answer for this question. Did you see the polarity? Did you see the polarity of this question? Who gave the answer A? See, basically, again, I'm saying whenever you go for this type of exam, I'm again saying that thing. If you are going for this BEL and other exam, these exams are easy. I'm again saying that thing. These exams are easy, but more focus on these type of questions where you can make mistakes. नहीं आंसर तो वो कहाँ दिख रहा है आंसर यार आंसर नहीं दिख रहा इसमें राइट Ganesh, where is the answer visible? Answer is not visible there. These are the options. Right? So here is the chance of getting wrong answers. Why? Because we think that it is a easy questions and we didn't consider the polarity of this voltage. Right? So basically what you can directly do, you can calculate the current I from here. That will be 20 divided by these two resistance, and these two resistance sum is 5. Right, the current is going to be 20 by 5, that is going to be 4 ampere. Understood everyone? We calculate the first current. Right, the current value is going to be 4 ampere. Now, if you go for this resistance, the voltage across this resistance is how much? 4 into 2, 8 volt with this polarity. When you go for this resistance, that is 3 ohm resistance, resistance into current will give you the voltage across that resistance, that will be 12 volt. But the polarity is plus here, minus here, right? This is 12 volt, this is 8 volt, right? What you are observing, this polarity and V1 polarity are same, right? V1 polarity and this voltage polarities are same. So V1 voltage is 8 volt, but V2 voltage is how much? When you go for this voltage source, its polarity is plus above, minus below. That polarity is opposite to V1. Focus on that thing always. I'm saying from the last class. If you attend the last session, there are also 2 or 3 questions like this. Yeah, voltage division you can apply, right? Voltage division is also possible here. You calculate the voltage division, 3 upon 3 plus 2 into 20, that will be give you 12 volt with the same polarity, plus minus here. And if you go for voltage division for this 2, that will be 2 divided by 2 plus 3 into total voltage 20. You can go with voltage division also, right? Right, GVD, GVF. Okay, let's move to the next question. Understood, everyone? More focus on these things, plus minus sign. There is a chance where you can make a mistake in this type of question. Elon Musk, right? Yes. What is the current through 5 ohm resistance in the circuit? This is a 5 ampere current source and this is a 10 ampere current source here. Try to solve it. We have to find the current in 5 ohm resistance. So everyone, you can join Nodal as you wish. Apply that one, what you want. I will discuss in the end. Right, I will tell you how you can solve it easily. Right, Saurav? 2.67. I don't know the answers for this one. I will show you later on, right? C. Okay, Madhu is also getting C. Antim Moria is also getting C. Right, right. Let's wait for the answer of others. C. Elon Musk. C. 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 Yes, correct, correct, correct. C is the correct answer for this question. Right, everyone getting C. So basically, in this question, no need to go for nodal, because if you go for nodal, right, Saurabh? If you go for nodal, then what happen? You are getting 2 voltages here, and you have 2 equations. You have to solve that these 2 equations. But the easy way to do that is voltage source transformation. This is what this is a current source in parallel with a resistance. We can convert this one into a voltage source. How much is that voltage of that voltage source? That is going to be, I'm making that circuit here. This is 4 ohm is come out to in series, then it is going to be plus minus 5 volt here. Next, this one is a 5 ohm resistance here. Now you could go for this one, that is going to be 6 ohm here, and it is plus minus, how much is that? That is going to be 60. So if you want to calculate, that will be the current through the 5 ohm resistance, current I, that is going to be how much? 60 minus 5 divided by 4 plus 6 plus 6 plus 4 plus 5. Sorry, that is 5 into 4, 20 volt. 20, it is 20. 5 into 4 is 20. So it should be 20. So it's going to be 40 divided by 15. 2.67. Yes, 20, 20. Correct, correct. Yeah, this is 5 into 4, that is going to be 20, then 4, then 5 as it is, then 6 as it is, then you can do that one. So this is the easiest way how you can solve that one. Don't go for nodal. Nodal is the last solution for you when you didn't get anything. So source transformation is the easiest way to do these type of questions. Okay, Saurav? Okay, let's start with this one. Circuit construct 2.66. Correct. Do it. Circuit construct B. Elon Musk B. 1 second. Yes, it is a time constant. D. Oh, minute. Madhu, it is not correct. The unit of this one, Srinidhi, is also not correct. D is not correct. D is wrong. See, basically, when you calculate the time constant, who got the C answer, sorry, D answer, that is not correct. The B answer is correct, right? B answer is correct. Why B is correct? Because the unit of time constant is second, not minute, right? When you go for time constant, that will be L by R. L is how much? 10 by 10. That is going to be 1 second. Remember that. These are the questions where you make a mistake, right? There is a chance where you can make a mistake. Sometimes you see that 1 second or 1 minute, right? So always remember the unit of time constant is second, not minute. Got it? Yeah, everything understood this. Yes, next. Why the transient response of the system is occur inside your circuits? Mr. Gautam B. Circuit construct, store energy. Yeah. So basically, whenever store energy, right? So Madhu, D is internal forces. No. Basically, whenever we are talking about the transient response inside the circuit will become only whenever you are having at least one energy storage element. Whenever you are having at least one energy storage element, then only you are having a transient response. If there is no energy storage element there, like capacitor or inductor, there will be no transient inside your circuit. Remember that thing. So if you are having one inductor, capacitor, two capacitor, or any combination of them, so in that circuit you always have the transient. So transient part will come inside the circuit due to energy storage elements. So what will be the answer for this question? The answer is energy storage. Correct? Right. Read this question. It is same type of questions asked in different way. Elon Musk, purely resistive circuit. Very good. Right, good. Everyone getting the correct answer. A, only resistive, right? Every time put your answer only once. Don't put again and again. Right? The one person is putting answer again and again. Don't put it again and again, only once. I will see the answers and I will react on that thing. Right? So answer will be A. Very good. Because it is a pure resistive circuit. So whenever a circuit is having transient response, for transient response that is required at least one energy storage, right, Gautam? at least one energy storage element. So inside a pure resistive circuit, there will be no energy storage elements is there, so there will be no transient response. Good. Let's go to the next question. Yes, do it. For a steady state. Yes, he's talking about for a steady state in sine wave. He's asking about, read the question, the transient current in loss free LC circuit when excited from an AC source results in what it will results. Priya says D, Elon Musk says A, Antim says D, Mr. Gautam says A. Okay. B, D, A, B, 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 A, B, B, D. We are not getting the same answer from that one. Madhu says A, Subham says A, Sirinidhi D. Someone says A, D. What do you understand with undamped, overdamped, critically damped, underdamped? What is the meaning of that one? If you studied your control system in detail, right, in that one, depend on damping factor. See, this is a LC circuit. How much is the damping factor of LC circuit? Anyone know that? Zeta, yes, zeta. If you go for LC circuit, that equation is S square plus 1 upon LC is equals to 0. Do you remember that its characteristic equation is like this? So zeta value is how much here? That will be 0. Right circuit construct? That will be 0. Because this is represents the omega n. Right, this is a oscillator. There will be sustained oscillations. If you draw its output is having sustained oscillation. Their amplitude is neither going increase nor going decrease. So if you go for this equation is only having omega n. So zeta value is 0. Zeta is 0 means what? That is undamped oscillations are there. Undamped sine wave is there. Undamped sine wave. Undamped means whose amplitude remains same. Right, Royal? Sir, explain all the condition when it occurs. See, basically, underdamped means what? Underdamped response, I think everyone understood. You studied that thing in your control system. Underdamped response is how much? That will be go like this and attain a constant value there. That is RC circuit. RC circuit is also having dampings there. You already studied RC circuit. Whenever you are having RC circuit, that is a first order system. That is not a second order system. Right? In second order system, we calculate zeta, omega n and these type of value. Your first order system response is similar to this one. If you go for that one, the first order response is like this. Right, Jasu? So this is not RC or RL circuit that are a first order response. The first order system, first order response is like this. We are going for the second order system. In second order system, because it is a L and C. Why we are saying this is second order system? Because it is having L and C. L and C make it equation that will be in the form of S square because there are two energy storage element. So if you go for second order system, underdamped response is like this. Undamped response is how much? That will be remain constant like this. Right? Overdamped means what? Overdamped means when your response is going to be increase and increase like this. Critically damped means what? Critically damped means what? The response is like this. Right, Saurabh? Yasu. So basically, this is only for LC circuit. LC circuit means zeta value 0. Zeta value 0 means your response is undamped sinusoidal. Your output will be a sinusoidal signal who is undamped, whose oscillation will be constant. Right? Do it. Nayak, there is no loss. It is never ending sine wave with zeta equals to 0. Right, Nayak? You are correct. Okay, this question. The gradient is defined at for each point of field. Okay, most of the answers are A. Deepika says A, right? Like Royal says A. Vaibhav says A. Vaibhav Raj Singh says A. Okay, I think A is correct answer. Gradient is a vector quantity that is defined for a scalar field. If you know, the gradient is defined as what? Gradient is del V. So where V is a scalar quantity, right? V is a scalar quantity. The gradient is a vector quantity with, and when you combine this one together, it will give you a gradient that is a vector quantity, right? So what will be the answer? The gradient is a vector defined for each point of a scalar field. Yes, correct. Answer is A for this one. Do it. So what you want to write? Gradient, vector, divergence, scalar, curl, vector. Okay. You are writing that gradient is a vector, divergence is a scalar, curl is a vector. Good. Elon Musk says D. Manas says A. Sirish Gupta says D. Rohit A. Scalar. Scalar. D. A. Most of the student, Madhu says D. Lovely size says A. Sirinidhi D. Vaibhav D. Okay. Circuit says, okay, what is the difference between this quantity and this quantity? Are they same or different? Scalar and constant. They are different quantity. Very good. They are different quantity. When I say the constant means, let us take you are having value 2 or 3, something like that. This is a constant value, right? And when we say this is scalar may be 2 or 3 or 4, but it can also be x square y z. This is also a scalar, right? So scalar required no direction. When you go for this divergence will give you a scalar value, not always a constant value. It may be give you a constant value, but not always constant value. It is always a scalar value. So don't be confused with these two terms, that is constant and scalar. So answer will be scalar. Always when you go for divergence always give you the scalar value. Divergence of a vector field will give you scalar value. Understood, everyone? Right? Should I go to the next question or should I explain it again? I think everyone understood this. If you have doubt, you can ask on the comment section. Right? Okay, do it. Which one of the fundamental equation was modified by Maxwell to form the basics of electromagnetic theory? On YouTube live section, you can get the live session right after the live. Okay, it says B, Ampere's law. Very good. The answer is V. Basically, whenever we talk about the Maxwell equation which is modified, that is del cross H for electrostatic fields, that is only have the JC. JC means what? That is having only conduction current density. Sirius Gupta, that is not D. Gauss law is not modified. Gauss law is remain same. Either you go for electrostatics or time varying field. That is remain same. The only modification, there are two modifications are there for that one. The first modification, del cross H is going to be JC for electrostatic field. Then we add another term here, that is JD. Right, Suresh? And this JD is called as what? Displacement current density. JC is conduction current density. So this is the modification in Ampere's law. So answer will be what? B. Clear? Okay. Do it. Which of the following is zero as applied to electromagnetic field? इलेक्ट्रोमैग्नेटिक फील्ड विच ऑफ द फॉलोइंग इज जीरो? कौन सा जीरो होगा भाई इसमें से इलेक्ट्रोमैग्नेटिक फील्ड के लिए? सी, डाइवर्जेंस ऑफ ए कर्व. B, Madhu says B, divergence of a gradient. See, whenever you go for divergence of a gradient, that will be a del square A, right? This is called Laplacian, and that will satisfy the if you go for potential function, that will satisfy the epsilon naught upon, sorry, rho v upon epsilon naught. This equation is known as Poisson equation, right? That is not zero. Always remember, divergence of a curl is always zero. Either it is electrostatic field or not. This quantity is always zero. Divergence of a curl is always zero. Remember that thing, right? So what he is asking, that which of the following is zero when applied to electromagnetic field? That is divergence of a curl, right? Divergence of a curl is always zero. Got it? Okay. Yeah, do it. Maxwell divergence equation for magnetic field is? Yes, please. What is the answer for this question? Elon Musk B, Sirinade B, Subham B. Subham, don't put the comment again and again. I understood your answer is B. Royal B, Kumar B. Okay, Saurabh, del dot B is zero. Okay, mostly getting the correct answer. This is why it is zero. What is the reason behind that del dot B is zero? The main reason for that one, that del dot B is zero, that your magnetic charge cannot exist separately, right? Similarly, if you go for electrostatics, the plus q and minus q are exist separately, but north pole and south pole also available in pair always. If you cut this magnet, they are also again, right, they are also getting again north pole and south pole, so there will be no monopoles in magnetic field. That's why del dot B is going to be zero. Correct. Very good. Next, Maxwell curl equation for static magnetic field is given by. Yeah. What will be the answer? Person says B, Subham says C, C, D, C, B. Oh, C, D, B. C. Susmita says D. Moria says AC. How AC? Okay, C. Shivani says C. C. Okay. See, basically the answer is del cross H is going to be how much? That is JC. If I multiply the mu both the side, then del cross mu into H is going to be B is equals to how much? Mu naught times J. So what will be the equation? That will be B cross del cross B is going to be mu naught into wait. Yeah, mu naught into J. Pawan, how it will be B? Del dot B is always 0. Right, Pawan? We already discussed this thing in previous question. Del dot B is always 0. Right, Pawan? डेल डॉट बी क्या होगा पवन? 0 है यार पीछे. ये डेल डॉट बी कैसे म्यू नॉट इंटू जे के इक्वल हो सकता है? डेल क्रॉस एच हमने पढ़ा था यार, पीछे क्या था? जेसी था. तो इट मींस डेल क्रॉस बी, इफ यू मल्टीप्लाई द म्यू नॉट ऑफ बोथ द साइड, then this h, what is the relation between? That will be mu naught into h, right? So that's why it is del cross b is going to be mu naught to j. Yes. What is the relationship between electric flux density B and electric field intensity is given as? Very good. Answer is C. Everyone getting the correct answer. D is equals to epsilon into E. Good, correct. Do it. The the drive unit of electric charge, the coulomb, is equivalent to what? Priyadarshini says B. Amperes per meter. That's not correct. Subham Kumar says A. Ampere second. Ampere second. Okay. Mithu Kumar says D. Utkarsh A. Prashant B. A, B, C, D. We are getting all the answers. A, B, C, C is also there. D is also there. A, D, A. A. Okay. A, B, C, D. Royal. How I can differentiate between these one? Okay. Circuit says that definitely A, as Q is equals to IT. Yes, very good. So basically, I is equals to how much? Q by T, if you remember, right? Q by T. So if we go for Q charge, that will be current times time, right? So Q is equals to IT. Current unit is ampere, time unit is second. So what will be the answer? Ampere second. That will be the another derived unit for volt. That is for charge. Remember, don't guess, just go for the formula. Right? Q is equals to I by T. That is going to be Q is equals to, sorry, I is equals to Q by T and Q is equals to I into T. Right. Next. See, these are the easy questions. You are making the mistake, just focus on the question. It's easy. It's not that much difficult. He says electric field intensity E due to Q is. What is electric field intensity due to a charge? Q. Let's move to 21. Okay, answer for 21st question. Start. C. A. Alon versus A. Force into charge. Okay, let's go for the definition of electric field. When you go to define the electric field, what is the definition of electric field? Electric field is defined as force per unit charge. Force per unit charge. That is the definition of electric field. So these questions are directly definition based. As you already know, the force per unit charge is defined as electric field. So force, if you divide the force by the charge, you will go to the electric field. So what will be the answer for this question? Answer will be C. Got it? So remember that when you go for electric field, the definition of electric field is that force per unit charge. Force per unit charge is electric field. Yes, next. Electric field intensity and electric potential are related by what? So let's go for 22. Answer the 22nd question now. 22nd question now. Yes, it's direct. Directly he is asking for electric field intensity and what is the relation between. No, not EMFT questions. There are all subject questions are there, right? That is E is equals to minus gradient of VD. Okay. Yes, what is the answer for this question? Now let's move to 23rd. So whenever you go total flux coming out of a closed surface, total magnetic flux, remember the meaning, magnetic flux. If he is talking about magnetic flux, you are having any closed surface like this and you are calculating to north pole and south pole, basically net outward flux is always going to be zero, because the flux which is entering in that surface is always equals to the flux leaving the surface. So that's why total flux out of any surface is going to be zero. Yes. Next, 24. Number of electric field intensity coming out to be surface will be zero. No, that will be equals to the charge enclosed by that surface. That is Gauss law, right, Saurabh? Suresh Gupta says C. The characteristic impedance of a lossless transmission line. Gautam, how it is D? Vinod Kumar, how it is D? Priyadarshini says B. How it is B? See, there are two things when you go for a lossless transmission line, its characteristic impedance is under root of L by C, and beta value is 1 upon under root LC. That is beta, phase constant. Yes, in transmission line, lossless transmission line, R and Z are 0. So answer will be C for this question. If you go for lossless transmission line, then the value of characteristic impedance is going to be under root L by C. Yes. Let's move to 25th question now. Do it. Which one of the following satellite system is most often used by global positioning system, that is GPS system? I'm getting only one correct answer till now. 2, 3. राइट सौरभ जियो अर्थ जो है जियो अर्थ सैटेलाइट बेसिकली जीपीएस में यूज नहीं की जाती, वो यूज की जाती है जब हम कम्युनिकेशन या फिर आप ब्रॉडकास्टिंग कर रहे हो कहीं पे, वहां पे जियो सिंक्रोनाइज और हाँ जियो सिंक्रोनाइज सैटेलाइट्स यूज करते हैं हम वहां पे, क्योंकि हमें एक पर्टिकुलर एरिया को कवर करना होता है. अब यहाँ पे क्या है, जब आप जीपीएस की बात करोगे, ए आंसर नहीं होगा इसका, ना ही जियो स्टेशनरी होगा, ना ही जियो सिंक्रोनस होगा, राइट. यहाँ पे क्या है, हमें पूरी अर्थ को कवर करना है, और पूरी अर्थ को कवर करते टाइम हमें क्या है, एटलीस्ट एट टाइम एक पोजीशन पे 3 सैटेलाइट होनी चाहिए. उसके लिए हम लोग मीडियम अर्थ ऑर्बिट यूज करते हैं. वी आर यूजिंग द मीडियम अर्थ ऑर्बिट फॉर दैट वन, so that we can cover entire earth, MEO satellites, right? Medium earth orbit in GPS, remember that thing. Yes, the perfect dielectric medium behave like a perfect transmitter of EM wave. This statement depends on what thing? Yes, Priyadarshini says A, Sasank says D, Suresh Gupta says D. It is true. Okay, depend upon the environmental condition. Oh, Elon Musk says A. Okay, A. How? See, basically, the perfect dielectric medium behave like a perfect transmitter of EM wave. Right. Okay, mostly giving the answer is A. See, basically, when you decide that your medium is a good conductor, yeah, D is true. D is the correct answer. D is correct. D is correct, right? Who's getting D answer? That is correct. See, basically, when we are talking about the dielectric medium, which is behavior like a perfect transmitter of EM wave, see, there is a one thing that is called as alpha. Alpha is known as attenuation constant, right? Alpha known as attenuation constant of a medium. If you are having a perfect dielectric, sigma value is 0, and as your sigma value is 0, alpha is always 0. Alpha is known as attenuation constant. Due to this alpha, your amplitude of EM wave will decrease. So if you are having a perfect dielectric, or right, if you are having a perfect dielectric medium, then you can directly get that alpha is going to be 0. If your alpha is going to be 0, it will not depend on the medium. Environment, not medium, environmental condition. It will not depend on the environmental condition. You can directly say for a dielectric medium, your alpha is going to be 0. If your alpha is 0, what it mean? The amplitude of EM wave remain constant throughout the medium, or you can say the EM wave can travel easily throughout the medium without attenuation. So it means it is a perfect conductor. The dielectric medium is a perfect conductor for EM wave. Got my point or not? So what it's meaning, that this condition is always true. It will not depend on any other factor. When you have a perfect dielectric medium, the EM wave can easily travel through that one. Got it? Right. The reflection coefficient of a short circuited line for voltage is, the reflection coefficient of a short circuited line for voltage is, yeah, correct. Yes. Everyone, I think, no, Ananda, you are getting the wrong answer. B. How? Reflection coefficient is how much? That formula for reflection coefficient, ZL minus Z naught divided by ZL plus Z naught. So if you are having a short circuited transmission line, then Mittu Kumar, you are getting wrong answer. When you are having a short circuited transmission line, what is meaning of that one? Right, this is the formula which I write it here. Short circuited means your ZL is going to be 0. Right, your ZL is going to be 0. When your ZL is 0, the reflection coefficient is going to be -1. So answer is A. Correct? Yeah. Now I think everyone understood this. Yeah, this is also a very good question. What is the unit of under root of L by C? Yes, correct. So L by C represents what? Z naught, characteristic impedance. That is L by C, and its unit is ohm. What is the unit of this one? That is ohm. I think it's easy question. Yes. Now let's start with control system questions after this. This is the first question from control system. System in which the output has no effect on control action is called as what? Give the answer for 29 now. That is a open loop control system. Very good. Very good. Good. Feedback control system. Srinidhi, how it is a feedback control system? It is an open loop control system. Right? When your output has no effect. In closed loop control system, your output will affect the input. Right, Srinidhi? So here, the output has no effect on input, control action. So it means that will be a open loop control system, not control closed loop, right? What is the difference between closed loop system, closed loop, and feedback control system? Both are same. Okay, let's move to the next one. A good control system has all the following feature except. What is the features of a good control system? किस चीज को छोड़ के क्या सारे फीचर होने चाहिए एक अच्छे कंट्रोल सिस्टम के? Pocket collection, basically, when you read the question, see, he says the good control system has all the feature following feature except. किसको छोड़ के? राइट, तो इस चीज का ध्यान देना, उसने पूछा क्या है आपसे? करेक्ट, उसने पूछा किसको छोड़ के पूछा है उसने. कई बार हम देखेंगे कि यार इसने पूछा गुड कंट्रोल सिस्टम के क्या पैरामीटर वो होने चाहिए, पहला ही दिखता है हमें सबसे अच्छा है. क्या दिख रहा है हमें सबसे अच्छा? यार गुड स्टेबिलिटी, है ना, तो हम वो मार देंगे. Circuit construct says D. Mithu Kumar says D. Why it is D? D means sufficient power handling capacity. That should be good. That should be having by your control system. But slow response. If your system, right, if you are having slow response, then how your system can behave correctly? Yes, yes, pocket collection. Always read the question correctly. I understood that why you are getting the wrong answer for this one. Right? So basically, the main thing, we need a fast response, not a slow response. Your system will respond fastly. Okay? Yes. Do it. 31 question now. In a signal flow graph, loop which does not pose any common node are known as. Very good, good, good. Correct, correct. A is the correct answer. I think everyone understood this. Yes, very good. Correct. Non-touching loops. The loops which does not have any common node, that are known as what? Non-touching loops. Good, very good. Next. Yes. Remember, this is in denominator thing, right? Like this. Like this. Like this. When the pole situated at s equals to -4 in the left plane, which represents in Laplace domain. A. Sigma greater than 0. Yes, A is the correct answer. If you go for this one, the poles are lying in the left half of S plane. It means what? That will be 1 upon S plus, yes, S plus 4. It means this will lie in the left side, right? And its value is going to be at -4. Very good. Good. How much is the order of this system? How much is the order of this system? Very good. This is correct answer. Correct answer is B. Everyone getting the correct answer. So order will be decided by this characteristic equation. And in this characteristic equation, we are getting the S square. That means its order is going to be 2. Good. The highest power is defined as the order of the system. Yes, do it. If positive feedback path is added to an open loop control system, then it loop gain may increase, stability is improved, stability may deteriorated, or B, both A and C. A, D, C. C, D, A. Elon Musk, how you got A? D, C. Priyadarshini, how you got C? Tejas got D. Utkarsh C. Utkarsh, how you got C only? So if you go for Rohit C only, if you go for positive feedback system, how much is the gain of that system? Transfer function or gain, both are the same thing. G upon 1 minus GH. हाँ भाई, क्या होगा पॉजिटिव फीडबैक के सिस्टम के केस में? यस करेक्ट डी. तो गेन क्या होगा? इट विल इंक्रीज द गेन. यस गुड. Pocket collection is correct. The gain is increased here, but the main thing is about stability. Your feedback decrease, then positive feedback will decrease the stability. So both are correct. It means answer is D here. Right? Okay, let's move to the 35th question. The presence of zero in a row while forming a Routh array indicates that the system has symmetrical location of root, is stable, is insensitive to the variation in gain, has asymmetrical located root. Shivani got D. A has symmetrical conjugate root. A imaginary axis पर होगा root, non repeated. हाँ जी, right. Bionic gamer says A. Saurav A. So basically, whenever you are having the row 0 in your Routh table, that will tell you that your roots are symmetrically located. That our roots are symmetrically located. So answer is A. Correct? Okay, do it. Next question. No, that is Jivant Kumar. That is not marginally stable, right? That is telling you that your roots are symmetrical. C B. A typical root locus diagram of a system is shown below. Find the point where the system is critically damped. So basically, when you go for critically damped system, the roots of critically damped system are what? If I go for critically damped system, see, whenever you are having a critically damped system, its roots are lying on the same place. So where we got the roots are lying on the same place, that is the position here. Where we are getting the roots are lying on the same place, that is critically damped system, right? Equal roots for your right track, that is equal roots, right? So whenever you are having a critically damped system that is having equal root, this is the root locus of your closed loop system. So in this root locus, what you are seeing, that there is only one position where your roots are lying on the same position, that is B. At C and D, the roots are cutting the j omega axis, where your system is undamped. Undamped. Right, Saurabh? That C and D is undamped. Bionic Gamer says D. None of these. No, B is the correct answer. Bionic Gamer, B is the correct answer, bro. There are two things. So when you go for your second order, right? When you go for your second order system and you go for the roots of that system that will be lying on the same place, equal or like. So when you go for underdamped system, the roots are complex, right? Complex and lying on the left side. So basically, if your roots are complex, like one root is lying here and one root is lying here, that system is what? Underdamped system, right? When your roots are complex. Other thing is that when your roots are equal, that will be critically damped system. The roots are equal for a critically damped system. When your system is overdamped, then your roots are unequal and real. So if your roots are lying something here and here, that means that will be overdamped. And when your roots are lying on the j omega axis, in that case, your system is going to be what? Marginally stable, or you can say undamped. How you are saying that roots are equal? Okay, bro. So basically, let us take, you are having a second order system that is twice zeta omega ns plus omega n square. This is the characteristic equation of second order system, right, Harsh? This is the equation for a second order system. So if it is the equation of second order system, critically damped means what? Your zeta value is 1. Right, Earth? Zeta value is going to be 1, then it is, this equation is become twice zeta omega n square. So this is the equation, right? This is the equation where you got s plus omega n whole square. Is this perfect square equation or not now? Tell me, Harsh. Right, this is a perfect square equation. Now if you calculate its root are lying on the same place, that is minus omega n, right, Bionic Game? Its roots is lying at minus omega n, right? Two roots, it is having two roots and both roots are lying at minus omega n. Right, so that's why what we can say, that roots are lying on same place, and that is the position in the root locus where the roots are lying on the same place. Understood, everyone? Okay, answer will be B for this one. So you can go for that one, the location of poles from the second chapter, right? From the second chapter you will easily get an idea that where your roots are lying. Yeah, zeta is equals to 1 for critically damped system. Okay, next question. 37 question. Just go for this one. Okay, answer is C. Sorry. Answer is C, is open loop zeros. So root locus is always end at open loop zeros, right? Yeah, if there is no zero, there is no finite zero, then root locus will go to the infinite. Okay. Yes. The root locus plot is symmetrical about real axis because, why it is symmetrical about the real axis? The answer is D, all of the above. The complex roots occur in conjugate or root occurs in pair. Root occurs simultaneously in the left and right half of S plane. How you can say that D is the answer for this question? Vaibhav. Sorry. Yes, Vaibhav Raj Singh. How you got the D answer for this one? Bionic Gamers is also getting D. Elon Musk is also getting D. See, basically, whenever he's talking about symmetrical about real axis, this is your real axis. This one is the real axis, not this one. The real axis is this one. If your root is symmetrical about real axis like this, one root is lying above, another root is lying above. How it is possible? It is only possible when you have complex roots occur in conjugate pairs. Understood? That is only possible. So reason for that one is complex roots occur in conjugate pair. If you are having a root 1 plus 2j, then there is definitely other root is, if your equation is having 1 plus 2j as a root, then definitely that will have 2 minus 2j as a other root for that one. Right, so that's make this system that make that your roots are symmetrical about your real axis. Got it? Okay. Right, unit is accepted for measurement of magnitude of Bode plot, that is decibel, dB. Decibel is the correct answer. Yeah, I think everyone know this. Right, let's move to this next question. He says the phase angle of a transfer function 1 plus j omega tau to the power n at corner frequency is. Yes. Yes, what is the answer for this question? The phase angle of transfer function at corner frequency is. Okay, Madhu, let's explain this one. So basically, this is a transfer function 1 plus j omega tau to the power n. So basically, if I write only for this one, I'm going for inside function. If I write the angle for this one, that will be tan inverse imaginary part upon real part. Real part is 1. Some people are missing n in North Pole. Okay, let's do this. So this is tan inverse omega by omega tau by 1, right? This is the angle for only inside part. If you take the power n, then what happen? That power will come into the multiplication. That is north, not north, right? That is minus 90 degree multiplied by n, right? So basically this is n times tan inverse omega tau. Now if you go for corner frequency, the corner frequency is 1 upon how much? That is 1 upon 1 upon tau. You can calculate the corner frequency here. That corner frequency omega c is what? 1 upon tau, and when you replace 1 upon tau here, that is become how much? 45 degree. So it is not 45, tan inverse 1 by 1, right? It is going to be n times 45 degree. That is plus because it is in numerator. Understood or not? Right? Its power is n in angle, that will become into multiplication. So that's why answer is B. 45 degree n. Repeat. ओके सौरभ रिपीट करना भाई. ऐसे बता, पहले मुझे ही बता, मेरे पास एक कॉम्प्लेक्स नंबर है 1 plus 2j, right? If I write its angle, that angle is tan inverse 2 by 1 or not? So same thing I do here. If I take this one 1 plus j omega tau, and I will write its angle is tan inverse imaginary part omega tau by 1, that is omega tau, right? and if it is tan inverse omega tau, if you take its power n, then power will always come into the multiplication of angle, remember that, right? It will come into the multiplication. Now go for the corner frequency. How you calculate the corner frequency in Bode plot? That will be inverse of pole. Corner frequency, how you calculate that one? Not inverse of pole. That corner frequency, how you can calculate that one? That is going to be how much? 1 plus, when you write it time constant form, that will be like this. So from that one, you calculate the corner frequency is going to be 1 upon tau. And 1 upon tau, when you replace in place of this omega, that omega cancel out, that is going to be 1. And tan inverse 1 will give you 45 degree. Right? I think everyone understood this one. Okay, let's move to the next. Yes, do it. D, D, B, D, D, C, explain, D, C, series B, D, B. B greater than 0. D, D, D. Okay, D. B, D. Okay, basically what he says, that you are having Nyquist plot of a loop transfer function g j omega of a system enclose the minus j omega minus 1 j 0 point. This is minus 1 j 0 point. If it is enclosed this one, it means your Nyquist plot is likely lying like this, right? If your Nyquist plot is lying like this, it means it will be cutting this real axis here, right? It will be cutting this real axis here, and at this position, if I calculate, because when it cut its real axis, that frequency is called as, where the phase is going to be minus 180 degree, that frequency is called as omega pc, because it is it is enclosing the minus j omega j minus 1 j 0 point. That means it will be lying at this left side of this one, and this frequency is called as what? Omega PC, phase crossover frequency. If your phase crossover frequency is here, then this value is called as what? The magnitude of the gain at that particular frequency. So from this figure, what we understand that this magnitude of G j omega H j omega at omega PC is going to be greater than 1. If this value is greater than 1, then minus 20 log, the gain margin is how much? Minus 20 log 10 base mod of Gj omega Hj omega at omega Pc. So this value is greater than 1. It means this log will give you the positive value, and outside the value is negative. Right? Outside value is negative. It means its gain margin is negative. Its gain margin is always less than 0. That make this system unstable. Got it or not? So this is the system how we got the gain margin as less than 0. Understood? And that will make this system unstable. So that is the complete reason behind that one. Okay, pocket collection, you are saying that repeated. Okay, this is the Nyquist plot or polar plot of a system like this. If you go for complete plot, that should be like this, right? I'm just making a random plot, right? This is a random plot, and in this one, what you are observing, if this Nyquist plot is enclosing the minus 1 j 0 point, it means that will be lying left side of this one. If it is lying left side of this one, where it cut the j omega axis, sorry, not j omega, real axis, that point where you got the angle of this system as minus 180 degree, because here is angle 0, here is angle 90, here is going to be angle 180 or minus 180, right? So at this position, what you are observing, the angle is minus 180 degree. So if your angle is minus 180 degree, that point is called as what? Where you got the phase crossover frequency. So this is the point where you got the phase crossover frequency. At this phase crossover frequency, the magnitude of this system is greater than 1. What you are observing, if you enclosing minus 1 point, that should be lying the left half of this point. It means this length is always greater than 1. It means at omega PC your magnitude is going to be 1, greater than 1. And if you put in the formula of gain margin, if your magnitude is greater than 1, let's say 2 or 3, that means this log 10 base, and that value will give you the positive value. If it is positive, minus sign is also already available in this one gain margin. So your gain margin is going to be negative or less than 0. Got it, pocket collection? So that is the reason why you are getting a less than 0 gain margin here. Yeah, do it. A DC constant voltage of a variable input voltage is called as. So gain margin is always be 0, not 0. That is negative in that case, right? Their gain margin is not 0. If that point, that the gain margin will going to be 0 if this Nyquist plot is coming from this one. If Nyquist plot is going through this minus 1 j 0 point, then it will be negative, right? Okay. Also that will be 0. Yes, this question. Yes, because of magnitude. Yeah, a DC constant voltage for a variable input voltage is called as, that is a regulator. Very good. Regulator is the correct answer, because it is provide you the constant output voltage when your input is variable. That is a regulator, not filter. Regulator. Regulator is a device which provides you the constant output voltage when your input voltage is variable to us. Got it? Okay. No, you can't directly say if it is enclosed, the system will enclose -1 J0 point. It will depend on the question, right, Siris? It will depend on the question. If both the junction of BZT is forward bias, then the BZT is in which region? That will be lying in saturation region, because both the junction are forward bias. I think everyone understood this one. It's easy. Do it. For PN junction diode, width of space charge region increase. What? By increasing the reverse bias voltage. By increasing the reverse bias voltage. As you increase the reverse bias voltage, your depletion region or your space charge region will going to increase. Got it? So answer is B for this question. Yes, do it. Find the current through this circuit where diode is ideal. So if your diode is ideal and you connect 12 volt, then diode will be replaced by short circuit, right? And the current is going to be 12 by 6, that is 2 ampere. So answer is 2 ampere here. Correct. What is the unit of mobility? 2, correct. What is the unit of mobility? Unit of mobility. What is the unit of mobility? Yes, please. The unit of mobility is meter square per volt second. So answer is B. Yes, meter square per volt second. The answer is B. Yes, do it. So if you calculate the mobility, mobility is going to be how much? Vd by E. Everything is given to you. Vd is 10 volt per centimeter and electric field is how much? Sorry, Vd is not this. This is electric field, not Vd. Yes, what he says, a small concentration of a minority carrier is injected in a homogeneous semiconductor crystal at one point. An electric field is 10 volt per centimeter is applied across this crystal. This moves the majority carrier at a distance of 1 centimeter in 20 microseconds. So speed is going to be 1 centimeter in 20 microsecond. 20 into 10 raised to power 6 is going to be above. So how much is that one? How much is that one? Yes, B. That is going to be 10 raised to power 6 divided by 200. So 200 is 1000 divided by 200 is 5000. That is centimeter square per volt second, because electric field is volt per centimeter and Vd is also going to be centimeter per second. Yes, this is the electron in outer orbit is called as valence electron. Very good, valence electron. That's correct, valence electron. The material which has largest number of free electrons and offers low resistance is called as what? Semiconductor or what? D, conductor. Very good, very good. Correct, correct. That is conductor. That is conductor. Good. Transistor is a power control device, voltage control device, or current control device. Transistor is what? Transistor is what? Voltage control device, current control device, or power control device? C. Pooja says C. Gautam says C. Ananda says C. Yes, good. Correct answer is C. Reddy, how you got D? Transistor Transistor is always a current control device. Inside the transistor, you can control the operation of transistor by with the help of IB. पावर कंट्रोल कोई डिवाइस नहीं होता भाई, जबरदस्ती नाम लिखा उसने यहाँ पे. MOSFET is voltage, right, Royal. That is current for BCT, and MOSFET is voltage control device. Correct. Yes, next. In a NPN transistor, when collector junction is reverse bias, emitter junction is forward bias, then transistor is operated in which region? That is active region. Very good. Good. D. गुप्ता जी, D कैसे आ गया? Yes, correct. Active region. You can see here a table, right? This is the table in which you are getting that which junction is forward bias, which junction is reverse bias. You can check it here, right? So in active region, your emitter base junction is forward bias, collector base junction is reverse bias. Then you can say this is an active region. You can take a screenshot of this one if you want. Yeah, let's move to the next question. हाँ जी भाई, एक बार फिर से मैं ये चीज बोल देता हूँ. तो परसों आपका एग्जाम है, राइट? डे आफ्टर टुमारो. So basically for that one we are going to have a session. So किस टाइम है भाई एग्जाम? मॉर्निंग में या कब है एग्जाम? टाइमिंग क्या है एग्जाम की इलेक्ट्रॉनिक्स वालों की? इलेक्ट्रॉनिक्स और इलेक्ट्रिकल की टाइमिंग 1 से 3. ओके, so basically you are having 1 to 3. Yes, after 3 we will have a session. अच्छा, 9 से 11 भी है? ओके, 2 शिफ्ट में एग्जाम है, 1 से 3 और 9 से 11. अच्छा, 11:30 रिपोर्टिंग है, या मॉर्निंग में भी है किसी का? 9 से 11. ठीक है, तो अगर आपका 1 से 3 एग्जाम है, 9 से 11 भी है, 1 बजे भी है. अच्छा, इलेक्ट्रॉनिक्स वालों का 8:30 रिपोर्टिंग, तो मतलब 2 इलेक्ट्रिकल 9 to 11, ईसी 1 to 3. सो ईसी के लिए हम लोग सेशन रखेंगे 3 PM के बाद. जैसे आपका एग्जाम हो जाएगा, हमने उसके लिए फ्री ग्रुप बनाया हुआ है भाई, उसमें आप लोग ज्वाइन कर सकते हैं. इसमें डिस्क्रिप्शन में लिंक डाला हुआ है उसका, तो वहां से आप लोग ज्वाइन कर सकते हैं उस ग्रुप को. एंड प्लीज डू वन थिंग, यू कैन पुट योर क्वेश्चंस देयर एंड वी विल ट्राई टू solve them and give you the feedback that which type of paper is that one, and we will give you the solution for that one which we get the questions. So try to do one thing, put the questions there, right? सर इवनिंग में भी है, 5 से 7 भी है इलेक्ट्रॉनिक्स वालों का ही. Okay. ग्रुप लिंक डिस्क्रिप्शन में डाल दिया जाएगा, वहां से ज्वाइन कर लेना सब लोग, और ठीक है, और वहीं से जाके आप लोग जब ज्वाइन कर लोगे तो वहीं पर अपने क्वेश्चंस पुट कर देना सारे के सारे, उनके सॉल्यूशन बना के फिर हम कल उस दिन ही लाइव करेंगे उसके बाद, ठीक है। फिर एक आइडिया लग जाएगा कि पेपर किस टाइप का था आपका, इजी था, मुश्किल था, तो उसी के अकॉर्डिंग फिर कट ऑफ भी आप लोग एक्सपेक्ट कर सकते हो, ठीक है। ओके सर, एक्सप्लेनेशन इज बेस्ट एवर एक्सपेक्टेड, Juliet. ओके, थैंक यू। हाँ भाई, ये यूट्यूब तो कमाएगा ही ना कहीं से, तो यार लाइव में भी ऐड देके करेगा ही वो तो कुछ ना कुछ, राइट। चलो इस क्वेश्चन पर आते हैं, फिर फटाफट इसको खत्म करते हैं यार, काफी क्वेश्चन पड़े हैं, अभी 50 क्वेश्चन पड़े हैं, आपका भी टाइम काफी लग जाएगा नहीं तो, ठीक है। डू इट। If two identical transistors each having current gain 50 are connecting in Darlington connection, the current gain of the connection will be. See, what will be the answer? B. Okay. Everyone getting the B answer? देखो, current gain is given to you beta, so beta is 50, right? Beta is 50. तो अगर आप एग्जैक्ट एनालिसिस में जाओगे इसके डार्लिंगटन पेयर के, इफ यू गो फॉर एग्जैक्ट एनालिसिस, देन द एग्जैक्ट गेन, करंट गेन इज बीटा इनटू बीटा प्लस 1. दिस इज द एग्जैक्ट गेन, बीटा स्टार, लेट्स से, right? This is so, because you no need to go in that much depth that how we can solve this question, you just memorize the formula, right? Whenever you see the identical transistor and that are connected in Darlington pair cases, right? Darlington pair connection, in that case what happens, in Darlington pair, the beta current gain is going to be multiplied with the gain of first and second transistor. This is beta 1 and this is beta 2. So what we are observing here, this 50 is very greater than 1, so generally we neglect this one. But if your gain is 20 or 10, you can't neglect this beta plus 1, right? If your gain beta is very greater than 1, then you can only go for beta star. That's value is going to be beta square, what you use here in this question. But exact form is this one for Darlington pair, remember that thing. So answer will be 2500. Okay, Harshit? Harsh, right? Harsh, basically you no need to go in depth on how you solve it, just memorize these formulas for this Darlington pair, right? Because it is not possible to explain everything about this Darlington pair here. Okay, let's move to this next one, right? Yeah, do it. Next question. The three different points are shown on a DC load line. The upper point represents what? So first, if you know how we draw the DC load line, the DC load line is look like this one. There are 3 points in the DC load line. The first point is here, leftmost point. This is how much? This is second point, third point is here, and second point is at the center. At the center, we are having the Q point. On this axis, which point we are having? That is VCC by RC, and it is always equals to I set. And how much is this point? That is VCC. These are the 3 points on the DC load line. So what will be the answer? Yes, please. The answer will be saturation point on the left side. So answer will be C here, not B. Q point is always at the center. Okay. The first point is saturation point, right? Saturation point what? Because at this particular point your transistor is in saturation region. Next is Q point. Q point is at the center of the DC load line, right? This is cutoff point because here IC is 0. At this VCC point, your IC is 0. This is called as cutoff point, where your transistor is lying in the cutoff region. Understood? Right, Harsh? Upper is saturation point, center one is Q point, right? And lower one is cutoff point. Yes, C is the third, VCC. He says that the dense point C is cutoff point आ रहा है सर. हर C point थोड़ी पूछा उसने यार, क्या पूछा है उसने? अपर पॉइंट पूछा है. देखो ये अपर पॉइंट कौन सा होगा भाई? ये होगा ना जो ऊपर की तरफ लाई कर रहा है, है ना? तो ये क्या होगा अपने लिए? सैचुरेशन पॉइंट होगा. Understood everyone? Let's move to the next question. Do it. In bipolar junction transistor, the base region is made very thin so that. Why the base region is made very thin? Good. Recombination in base region is minimum. That's why the base region is made of, right, very thin, so that there will be less recombination there. Correct. Got it? Okay. Yes. Do it. The output of VI characteristic MOSFET has. Yes, very good, very good. The ohmic region has low voltage followed by saturation region at high voltage. That's the correct. As you already know that when your VDS is less than VGS minus VTH, right? That region is known as ohmic region, and when your VDS is greater than VGS minus VTH, that region is known as what? Saturation region. Right? So basically your transistor will be operated in two regions when it will be on. At low voltage at ohmic region, and at high voltage it will be in saturation region. Got it? That's the explanation for this one. Yes. Next question. Solve it. Yes, correct. RC minus RC over RE is the voltage gain of common emitter amplifier. That is the direct formula. Right, you can go for the complete derivation. I'm not going here because it will take lots of time. So you can go for this formula, that is RC over RE. You have to draw the AC equivalent circuit for that common emitter configuration. Then you will directly quote this minus RC over RE. Right, remember it. Yes, do it. Minus sign indicate that it will provide you the 180 degree phase shift to the input signal, right? Right, Gupta ji? माइनस साइन बेसिकली यार जब आप उसका इक्विवेलेंट ड्रॉ करोगे ना, तो बेसिकली यहाँ क्या होता है अपने पास GM इंटू VGS, एंड यहाँ आपका जो रेजिस्टेंस लगा होगा RD RE जो भी लगा होता है, ठीक है, यहाँ से GM इंटू VGS या R पाई जो भी ट्रांजिस्टर लिया है या MOSFET लिया, क्या लिया उसने, हाँ ट्रांजिस्टर की बात कर रहा है वो, तो यहाँ GM इंटू वी पाई आएगा, राइट. वी पाई आपकी यहाँ की वोल्टेज होगी. तो बेसिकली व्हेन यू कैलकुलेट द आउटपुट वोल्टेज, द करंट इज गोइंग इन दिस डायरेक्शन, इट मींस आउटपुट वोल्टेज इज ऑलवेज गोइंग टू बी नेगेटिव. दैट्स व्हाई. Okay. An oscillator of LC type that has tapped inductor in tank circuit. Yes. That has tapped inductor in tank circuit. That will be Hartley oscillator. Very good. अगर कैपेसिटर होता टैप्ड कैपेसिटर होता तब कैसा होता वो कोलपिट oscillator. Remember. Okay, very good. Yes, that is the equation. An amplifier coupled capacitor is used to why? And in an amplifier, coupling capacitors are used. Why? Generally, the coupling capacitors are used to block the DC signal, right? To prevent DC mixing with output. To prevent DC mixing with output. Because at DC, the capacitor will provide you infinite impedance. That's why. Okay, do it. Determine the AC dynamic resistance of a diode if current varies from 2 to 17 milliampere and voltage varying from this one to this one. So how much is that? Change in output voltage divided by change in input voltage, right? Change in output voltage divided by change in input voltage. That will be 0.725 minus 0.665 divided by 17 minus 2. So when you subtract them, how much we got? Zero point 0.075 divided by 15. So that gives you around 5 ohm. Answer will be C. Because this current is in milliampere, remember. So let me write it here. 10 raised to power minus 3 is also there. So when you go take it up, that is going to be not 5 milliohm. How it is 5 milliohm? So it is milliampere current is here. When you take this, is going to be 1000 there on the top. So it will be 1000 times 75. That so 1000 times 0.75, and that will going to be 75. 75 by 15 is going to be 5 ohm. Got it? Okay. Okay, let's do the next. Internal device capacitance become more predominant in. Okay, sir, understood your point, what you are saying. C, at low frequency region, internal capacitance, right? He's talking about internal capacitance of device. Like let us take an example of MOSFET or your BJT. Inside the BJT, there is their internal capacitance is what? C pi, C mu, right? He's talking about that thing. So internal capacitance are more predominant in high frequency. High frequency. So answer is high frequency. And when he talk about low frequency, at low frequency your coupling capacitors will be more effective. At low frequency coupling capacitor, and at high frequency he is talking about, then there will be what? Internal capacitance. Yes, please. What is the answer for this question? He's asking for IL. Sakshi says B. For this one, okay, previous question. Right, right. Sasank says 5 milliampere. Good, correct. 5 milliampere is the correct answer because as you see, no current is going to be inside the op amp. So it means the voltage is here 0. So that voltage 0 voltage here. So if you go 10 minus 0 divided by 2, that will be the 5 milliampere current is here. The same current will go up. So it will be 5 milliampere here. The same current. Answer is A. Very good. Correct. Everyone got the correct answer for this one. Yes, this is also a very good question. Right. An ideal voltage amplifier has an ideal voltage amplifier has good. C is the correct answer. Right, good, good. Everyone getting the correct answer? Right. C is the correct answer. Because input impedance should be infinite so that there will be total input voltage will go there and output impedance should be low. Yes. Do it. The voltage gain versus frequency curve of an op amp is shown in the figure. The gain into bandwidth product of op amp is. Do it. Gain into bandwidth product. C. Saurav says C. Jack Sparrow. Okay, Jack Sparrow says C. 200 kilohertz. Yes, C is the correct answer. Good. C is correct. Very good. So what you are observing here, the gain of the amplifier is 80 dB. When you convert this 80 dB into normal, so 80 is going to be 20 log of 10 base. Let's take gain G. So G is going to be 10 raised to power 4. So if your gain is 10 raised to power 4 and bandwidth is how much? That is 20. Right. So this is the bandwidth. So gain into bandwidth product is 10 raised to power 4 into 20. That is going to be 200 kilohertz. The answer is going to be C. नहीं नहीं सौरभ, गेन इंटू बैंडविड्थ प्रोडक्ट का भी आपका जो है यूनिटी मतलब किसी केस में हो जाएगा पर हर जगह यूनिटी नहीं होता. गेन इंटू बैंडविड्थ प्रोडक्ट हमेशा कांस्टेंट होता है. Yeah, we are talking about Gupta ji, we are talking about that gain into bandwidth product is infinite for ideal amplifier, not practical amplifier, right? It is practical amplifier gain curve. Yes, do this. An ideal op amp is an ideal op amp is an ideal. What is that? Voltage control, voltage source, current control. Yes, do it. An ideal op amp is an ideal, what is that? Voltage control, voltage source, current control, current source, what is that? Voltage control, voltage source. Ideal op amp is voltage control, voltage source. So answer is B here. Yes, B, that one. Do it. मैं दो बोल रहा हूँ सर, इसको 4 ईयर था अभी ना, कौन सी आरसी आने की मेरी ना 10 नंबर वाली. हेलो दुष्यंत, यार ये 10 नंबर में ना हमारा मकान अभी बन रहा है, हमने पीछे रहता है. अब 10 नंबर ये पड़ता है यहाँ पे जो सरंज निकंकाई भवन नहीं है, इस वाली गली जाती है जो प्रेस वाला बैठता है, इसके साइड पे जो है वहां पे पड़ता है. आप कहाँ पे हो सर अभी? है ना, उसी के साइड में इधर बन रहा है मकान ना, वहां पे है. तो मैं वाइफ को भेज देता हूँ. आप 23 नंबर पे दे सकते हो सर, इधर जो पीछे की तरफ है 23 नंबर गणेश मंदिर के पीछे की तरफ, ब्लैक कलर के गेट में लास्ट घर जो है, राजेश कंबोज के नाम से है. हाँ जी हाँ जी, वहां पे दे दो सर आप ना, वहाँ वाइफ रह मेरी घर पे भी ना. Sorry for the delay, right? Oh, I got a call, right? Okay, let's start. The order of sustain the oscillation, the Bragg-Hussein criteria state that what is the Bragg-Hussein criteria for that one? D. None of these is correct. The loop gain of the circuit should be equals to 1 with phase shift 180 degree. Is that not correct? It is undamped oscillation, then NA due to sustained oscillation, 0 or 360 degree. Yes, correct. Bragg-Hussein criteria, when you are getting the magnitude should be equals to 1 and your phase should be either 0 or it should be 360 degree or integer multiple of 360 degree. No, sir. 0 or 360 degree. Yes, answer should be there. There should be 360 degree here. Phase shift of 360, not 180 degree. If that's 360, then it will be 1. Correct. Okay. Yes. Now move to the signal and system part. Signal and system part, right? Impulse response of a LTI system is given to you, then system is what? Stable, unstable, causal, non-causal. What was that? So first thing, we are talking about the causality of that system. This is causal or non-causal? That system is non-causal because its response is started from -3. If it is a causal system, then its response should be 0 for n less than 0. But that is not 0 for n less than 0. So it is non-causal. Next thing, if you are going for stability, how you can check the stability of a system? Its stability, you have to check that mode of Hn summation n is equals to minus infinity to infinity, that should be less than infinity. And this graph is exponentially decaying graph, right? Like this, it's exponentially decaying graph. If you add them together, it will give you a finite value. It means it is always less than infinity. So this system is stable and non-causal. Remember that the answer is B here. Stable and non-causal. Got it? Yeah, I think everyone got the correct answer for this one. Good. Yes, the signal xt is equals to 3 cos of 5t plus pi by 6 is a periodic signal with a period of how much? How much is the period of this signal? Yes, do it. Now do the 67 question, right? Do it. Yes, very good. So if you go for this signal, this is the omega naught. Omega naught value is 5 and omega naught is 2 pi by t. That is going to be 5 and the t value is going to be 2 pi by 5. 2 pi by 5. Right, very good. Answer is C here. Which of the following is a non-causal system? Yes, which of the following is a non-causal system? Okay, move to this question now. 68. Non-causal. T of xt is non-causal. Okay. What is the definition of a non-causal system or causal? Sorry, first go for causal system. What is the definition of a causal system? The causal system is the system whose output is depend on present as well as the past input. Present as well as the past input, not future input. Not on the future input, right? So if you go for the first system, yes, if you go for the first system, what you are seeing in the first system, this output is depending on two values. This xt, this is present input, this is also xt here, this is also a present input, so it is a causal system. Now go for the second one, this is present and this is past. If you replace at t equals to 0, t equals to 0 means if you are standing at t equals to 0 currently, so what you are observing, you are having an input at x equals to 0, which is the present time for me. If you go for this one, that is x of -1, that is the past time for me because I am standing at t equals to 0. So t -1 time is past time for me. Understood? So this is past input, this is present input. So it is depending on past as well as present. So it is causal. Now go to this one. You have to check only input, right? Not about the time. If you are checking the input, this is the input here, xt only. So if it is xt is the input, that is what? Present input or past or future? That is present input. So this is also causal. But if you go here, what you are observing, if I replace t equals to 0 at, if you are standing at t equals to 0 currently, right? At t equals to 0, that this is become x of 0. So this input will be present input for me, but this is going to be x of 3, right? This is going to be x of 3, that is a future input for me. That make this system non-causal. Got it everyone or not? Static means whose output depend on present input. Present input only. Yeah, Captain Jack Sparrow, you can go for the ROC also, but you can directly check on the from that conditions which I told you. Understood everyone, right? The answer will be D for this question. I explain each and every answer for you, right? Okay, let's move to the next. Yes, do it please. Convolution of a function f of t with unit impulse function will give you what? D. This is convolution, not multiplication. It is convolution, not multiplication. See, basically everyone know this thing and make the mistake here. Why you are getting Weber? Why you are getting D? Pocket collection. Why you are getting D? It should be A. Right? Because when you do the convolution of any signal, this is convolution with the impulse, that will give you the same signal, f of t. Why you are not focusing on question? You are just hurry in the giving the answers. That the same thing. This is the same thing will happen in you with the exam. If you didn't focus on the question, everyone, right? Just focus the question because I know everyone know these things. D is not. Arnav, how you got the D? D is multiplication. When you do the multiplication of f of t with delta t, that will be f of 0 into delta t. That is f of t into f of 0 into delta t. If it is multiplication, not convolution. Right or no? If it is convolution, then that will be f of t. Understood or no? Yes, I think everyone understood this. So be focused because there is a very high chance to get mistake in these type of questions. Yes, do it. Pocket call is B. Teza getting D. Persona getting D. Yes, signum is odd function. Correct. That's the correct pocket collection. Okay. Elon Musk is getting C. I get only two answers correct till now. Only two answers are correct. Rest are wrong. Only two answers. This is a tricky question. It's not like you can just see the question and put the answer there. Only two questions. Yeah, one more correct. One more. Now it's correct answers are going on. Yes, yes. C is the correct answer for this one. C is the C. Not pocket collection. Differentiation is not zero. That is integration. Integration when you do from minus a to a f of t and f of t is odd function. That integration will be zero. Not differentiation. Got it? Yeah, it is differentiation. Differentiation, if you draw the graph of that one, that is minus 1, that is plus 1. If you take the derivative of this one, all the other sides this become 0, because at the origin we are having a sudden change. What you are seeing here, at the origin we are having a sudden change. Whenever you see a sudden change, there will be the impulse there at that particular position when you take the derivative of that function. So what you are seeing, there is a step change from minus 1 to 2. How much is the step change? That is twice. So you are moving twice from minus 1 to 2. So there will be an impulse whose strength is 2. So it means if you take the derivative of this function, d upon dt, that will give you the impulse signal at origin whose strength is twice of delta t. Now understood everyone? So answer is twice of delta t. So be focused on the question, what is asking. Any doubt in this one? That is signum function. Signum function SGNM. SGNT. Signum function. Its value is 1 for t greater than 0. Its value is minus 1 for t less than 0. This is called signum function. This is the standard notation. Right, Harsh? I think everyone understood this question now. Let's move to the next one. Yes. Or either you can go like this also. This is simple. So twice ut minus 1, and then you can take the derivative. One derivative is 0 and you are getting twice ut, and that derivative is going to be twice of delta t. You can use this one's vertical expression also. Right, do it. Minus 1 to 1. Evaluate minus 1 to, this is minus 1 to plus 1, right? Not negative 1. Sasank, 4. How you get the 4 answer, Sasank? How you get the 4 answer? Why you are putting again and again? I'm seeing your answers, everyone answers. Sasank, yes, that will be 1, not 4. Correct. So this is your f of t. So f of t into delta t is how much? That is going to be f of 0 into delta t. And we put t equals to 0 inside this one. So we are getting minus 1 to 1. That is going to be 1, and times delta t into dt when you put t equals to 0 here, and take the integration of that one, that will result in 1. So answer is 1. Yes, area under the impulse curve is 1. Good. Yes. Do it now. प्रशांत श्रीवास्तव, डू इट. भाई गेट की बात बाद में करेंगे, अभी बीएल का चल रहा है, अभी बीएल का डिस्कशन करो. राइट, क्वेश्चन करो ये क्या है. ठीक है लाउडोज. सेम साइन चेंज से एक्सपोनेंशियल शिफ्ट होगा. बी बी अर्णव ए बी. what is at 0? At 0 this is having a discontinuity, right Sanjeev? It is having a discontinuity. Ideally that value will not be defined, but by using the Gibbs phenomena that value is going to be 0. Previous value and past value. When you add them together, take the average of that one, that makes that 0. Right, Siri? Sanjeev? जूम करना पड़ेगा, दिख नहीं रहा यार, जूम करके तो ज्यादा फिर वो हो जाएगा. Elon Musk says the function is shifted in time domain by t naught, then its Fourier transform is multiplied by which factor? देखो, basically what he says that you are shifting a function that should be plus and minus t naught. It may be plus or it may be minus. It may be plus or minus because he says shifting. He is not telling us that we have to do the shifting by left or right or we have to do the advance or delay. He is not talking about that one. Right? He is not talking about that thing. So that's why if you take its Fourier transform, that will be e raised to the power plus minus j omega t naught multiply with x of omega. So it means what is happen, its answer may be a or b, you can put any answer. Sometimes he will bring the right, there is no mention in left and right, that's why it can take this one also and this one also, both are correct. Right, yes, do it. The Fourier series of a function is a. Correct. Sasank correct, Saurav Kumar correct, Elon Musk correct, Sirinidhi answer is a correct, very good. So this one is answer is correct, a. This answer is a. How? This can be converted into cos 2 theta formula, that is 1 minus 2 sine square theta, and from that one if you calculate sine square theta value, that is going to be 1 minus cos 2 theta divided by 2, 0.5 minus 0.5 cos of 2 theta. Right, and see, basically directly this is the expression in Fourier series form. No need to go in Fourier series for this type of question. Right, but he is asking for Fourier series. This is the math question. It is directly formula, nothing else. Right, A is correct answer. Yes, do it. Next question. The amplitude spectrum of a real signal xt is. The amplitude spectrum of a real signal xt is. Good, correct. Correct. So whenever we are going for the amplitude spectrum, that is always an even function. It is always an even function. Very good, correct. Yes. Fourier series functions of a periodic signal with half wave symmetry contain. This PDF is not available anywhere. I just made this question 2 days back, right? I didn't upload anywhere this one. They studied these things. They are not giving the answer in advance. When they see the question, they will give you the answer, because these questions are not that much difficult. This BEL exam is not that much difficult. It's easy exam. That's why, Sakshi, they are giving the answer for these questions. See, I'm again saying this is the BEL level. You will understand from these questions. This type of question will ask in BEL exam. But most of the thing is that you have to be focused on the question, what he is asking there. Fourier series function of a periodic signal with half wave symmetry contain only odd harmonics, that is directly, right? Whenever you are having half wave symmetry, inside the half wave symmetry, the main thing is that, so basically for that one, a naught is how much? That is going to be 1 upon t integration minus t by 2 to t by 2. If you go for Fourier series, t by 2, then that will be xt dt. And next is, if you're writing an is going to be 1 upon t integration minus t by 2 to t by 2 xt cos of n omega naught t dt. And bn is going to be how much? That is 1 upon t integration minus t by 2 to t by 2 xt sine of n omega naught t dt. So basically, whenever, yes, BDL level is also same as BEL level, right? See, basically this is, if you are having odd signal, right? Odd signal, what you are observing, odd signal, this A naught is going to be 0, right? And here, if xt is odd, then odd multiplied by even is give you odd signal, and that odd signal, when you integrate from minus t by 2 to t by 2, that is also 0. So an is going to be 0. If you are having a odd signal, then your A naught is 0 and an is definitely 0, but dn can take any value, bn can take any value, right? So it means if you are having a odd signal xt, in odd signal xt, the Fourier series expansion can contain only sine terms. Remember that. Why? Because its bn is non-zero, an and a naught is 0. If you go for even signal, xt is even, then this an is finite, this, sorry, a naught is finite, an is finite, this a naught is finite, an is finite for even signal. They cannot be 0, maybe 0, but may be finite, right? But we can definitely say that bn is going to be 0. We can definitely say that bn is going to be 0. Why? Because xt is a odd signal and sine of n omega naught t is, sorry, xt is even signal and sine of n omega naught t is odd signal. When you multiply even with odd, that will result a odd signal, and odd integration from minus t by 2 to t by 2 is going to be 0. So we can say that bn is definitely 0 here. So that's why whenever you are having a even signal, that is only contain the DC term and cosine term. And when your signal is having half wave symmetry also, then half wave symmetry is only having the odd harmonics. Odd harmonics. I'm not going to derivation of that one. So remember that whenever you are having a half wave symmetry inside any signal, that is having odd harmonics only. That's why. That's why we are getting these types of things. Understood? I think everyone understood these things. Okay, let's move to the next one. Just do it. It's easy. Tarkli formula. I think everyone understood this. The sign of at is ut Laplace transform is what? A upon s square plus a square, right? And that will be real part of s is always greater than 0. So answer is C. Good, correct. Yes, do it. Yes, correct, correct. C is the correct answer for previous one. This is the directly formula for what? Yes, correct. C. That is 1 upon A plus j omega. Fourier transform formula. Do it. नहीं सौरभ, ये कभी नहीं करना भाई. लाप्लास ट्रांसफॉर्म में एस इक्वल्स टू जे रख दिया आपने, जे ओमेगा रख दिया. वहां से दिक्कत क्या आएगी लाप्लास ट्रांसफॉर्म में कि फोरियर ट्रांसफॉर्म कुछ सिग्नल्स का डिफाइंड नहीं होता. लाप्लास ट्रांसफॉर्म सारे सिग्नल्स का डिफाइंड होता है. तो वहां क्या होगा आपका, जिनका डिफाइंड नहीं भी होगा उनका भी डिफाइंड करके आप आंसर कराओगे. तो ऐसा मत करना कि आपने लाप्लास लिखा और एस की जगह जे ओमेगा डाल दिया. वो केवल उन्हीं सिग्नल में कर सकते हो आप, उन्हीं सिग्नल्स में कर सकते हो जो सिग्नल एब्सोल्युटली इंटीग्रेबल होंगे. अगर एब्सोल्युटली इंटीग्रेबल, हाँ जी, जो जे ओमेगा एक्सिस को इंक्लूड करेंगे उसी में आप एस इक्वल्स टू जे ओमेगा डाल के लाप्लास से फोरियर ट्रांसफॉर्म में जा सकते हैं. गॉट इट? अदरवाइज नॉट. या डू इट. द फोरियर ट्रांसफॉर्म में भी कंटिन्यूअस टाइम सिग्नल xt is equals to e raised to the power minus a mod of t. That will be 2a upon a square plus omega square. So answer is B here. Correct. Yes, Laplace transform of delta of t minus 2. How much is that? How much is that? C, very good. E raised to the power minus 2s. That is directly shifting property of the Laplace transform. Yes. The initial value of f of t with transform f of s is given to you. How much is the initial value of this function? How much is the initial value? So what we can do, we can directly apply the initial value theorem there, and we will get the initial value for that function from that one. What is the initial value theorem? That says that if you are calculating f of 0, that will be limit s tends to infinity s into f of s. This is initial value theorem. Right, Deepika? You are applying the final value theorem for that one, Deepika. That's why you are getting the D answer. Prashant is also getting 1 by 6. Vibor is getting also D answer. That is not correct. Pocket collection is also getting D answer. That is not correct. D is the wrong answer because you are applying the final value theorem, not initial value. Pocket collection, that is D is wrong answer. I'm again saying. Right? That is s tends to infinity. So how we can solve it? Limit s tends to infinity s times s plus 1 divided by s plus 2 s plus 3. So what we can do? We can take the s common from the numerator. So it is become s square 1 plus 1 upon s divided by, you can take s from here. So it is become 1 plus 2 by s, and it is become 1 plus 3 by s. Right, s is square outside, and this s square cancel out, and you replace s is equals to infinity there. So its value is going to be 1. Right, so answer is B. Sasank, not C, that is B. Check it again. So don't be confused with initial value and final value theorem. Right. Okay. Let's move to the next. Right. Do it. Now we are moving towards the communication part. चंदन भाई कंप्यूटर साइंस नहीं आती मेरे को ना, मैं इलेक्ट्रॉनिक्स से ही हूँ बेसिकली. Do it. So he says that SSB system with upper sideband transmission, if carrier frequency is 1 megahertz, the highest frequency component in the message is 5 kilohertz, which frequency will be present in transmitted signal. So basically, whenever you are talking about, very good, right, Saurabh. That is FC plus FM. Right. So basically, when you are going for the highest frequency, frequency component in upper sideband, he is talking about the SSB, which is upper sideband transmission. So upper sideband will have FC plus FM frequency. So when you add FC, the carrier frequency, 1 plus kilohertz is 0.0. Convert that into megahertz. So 1 plus 0.005. So answer is going to be 1.005. हाँ जी सौरभ, पता है मेरे को यार, इलेक्ट्रॉनिक्स से हो आप. एक ना वो पूछ रहा था कि कंप्यूटर साइंस का भी ले लो सर आप ऊपर, इसीलिए बता रहा था भाई, मैं कंप्यूटर का नहीं लेता. ठीक है, चलो इसको करो. एंगल मॉड्यूलेशन इंक्लूड विच ऑफ द फॉलोइंग टाइप ऑफ मॉड्यूलेशन? हाँ जी, सर्किट कंस्ट्रक्ट क्या कह रहे हैं? आइदर ए कैन ऑल्सो बी. ए कैन ऑल्सो बी. ए कैसे हो सकता है भाई? उसने अपर साइड बैंड लिख दिया ना यार, यहाँ पे देख, अपर साइड बैंड एसएसबी लिख दिया ना भाई. राइट. यहाँ पे क्या लिख दिया आपने? अपर साइड बैंड लिख दिया यहाँ पे. ठीक है, अपर साइड बैंड अगर लिख दिया तो फिर कैसे आएगा ए? आंसर क्या आएगा इसका? बी. डू इट. The angle modulation include which of the type of modulation? Phase modulation and frequency modulation. सेफ स्कोर भाई, सेफ स्कोर आप 90 प्लस मान के चलो, चाहे आपके कैसा भी एग्जाम है, अगर आप 90 प्लस स्कोर कर रहे हो, 90 टू 95 के बीच में स्कोर कर रहे हो तो सेफ स्कोर है. Frequency modulation, the frequency deviation is delta f, that is kf into am. Kf into am, right? So it will be depend on the what? Circuit construct. B, the frequency of carrier signal. How this will depend on frequency of carrier signal? This is depending on this kf and am. Right, am is the amplitude of modulating signal. So answer is A. This is amplitude of carrier signal. Read the question. Carrier signal will not change that thing. Right, Harsh? Right, Harsh? John, I'm teaching since last 7 years. 7 to 8 years. And since I'm teaching each and every subject from electronics, including math also. In frequency modulation, the frequency deviation is proportional to. डिजिटल भी आएगी, टेंशन नहीं लो, आएगी, डिजिटल भी आएगी, सब आएगा, है ना. आंसर क्या आएगा इसका? ए. डिजिटल ही बची है, अभी डिजिटल आएगी इसके बाद. ओके, नेक्स्ट. व्हाट इज द मेन एडवांटेज ऑफ ईएससी की क्लासेस भी लेता हूं यार. What is the main advantage of frequency modulation over amplitude modulation? What is the advantage of, very good, that's correct. Correct answer is better noise immunity, right? So basically your FM signal will provide you better noise immunity, but the bandwidth requirement of FM is higher as compared to AM, but it is provide you better noise immunity. That's the correct answer. Good. The phase modulation, the phase deviation is directly proportional to what? The phase modulation, the phase deviation is directly proportional to what? हाँ भाई कितना होता है phase deviation delta phi? Frequency of modulating signal, amplitude of modulating signal, carrier frequency, power of modulating signal. कितना आएगा ये kp इंटू am? तो ये भी क्या करेगा, एम्पलीट्यूड मॉड्यूलेटिंग सिग्नल पर डिपेंड करेगा. चलो आगे चलते हैं. हाँ जी. Yes, you will get this PDF in the app, right? We will upload that there. Don't worry about that. Right, Haricharan? Okay. Next question. If the modulation index of FM signal increase, what happened to the bandwidth of the signal? If modulation index of FM signal is increased, what happened to the bandwidth? That will increase, decrease, or what? Yes, it will be increasing. If you go for the bandwidth, that will be how much? Twice. Right, Carson rule. So directly write it in terms of beta, twice delta f plus fm, and you can write that one twice fm beta plus 1. If you increase the value of beta, then your bandwidth is going to be increase. Yes. If frequency modulation, in frequency modulation, yes, how does the bandwidth of a multi-tone modulated signal compare with single tone signal? स्क्रीन नहीं दिख रही भाई. स्क्रीन तो विजिबल है यार, मेरे को भी दिख रहा है लाइव में, विजिबल है स्क्रीन. चेक करो एक बार. यस, मल्टी टोन एफएम रिक्वायर मोर बैंडविड्थ देन द सिंगल टोन एफएम. वेरी गुड, करेक्ट. Multi-tone modulation required higher bandwidth, because if you go for the bandwidth formula, bandwidth is going to be how much? Twice of delta f plus fm. So basically when you are having a multi-tone modulation, that delta f is higher than the single tone modulation. That's why we are getting the multi-tone modulation fm require the more bandwidth than the single tone fm. Correct? What is the primary advantage of FM stereo multiplexing over MAMO FM transmission? Do it. Memo transmission means what? When you are transmitting only in one direction, right? Stereo multiplexing, you are transmitting in both the direction, right? From left to right or right to left in audio channels. So what will be the answer is the ability to transmit left and right audio channel separately. That is the ability. C is the correct answer. Very good. Correct. This is good question. In the indirect method of FM generation, that is Armstrong method, what role does the phase modulator play? What is the role of phase modulator there? Yes. A. What is who is getting A? Haricharan, A is not correct. That is the basically what it will do. It will convert the phase change into the frequency variation. Generally, in Armstrong method, first we convert the phase change into, yes, it can change the phase change into frequency variations. First we change that, so it will be precisely give you the frequency modulated signal. So answer is it convert the phase change into frequency variations. Yes. These type of questions generally we did not study in the gate courses, right? The Foster-Seeley discriminator is primarily used for which purpose in FM receivers? Generally, this Foster-Seeley discriminator is a frequency demodulator. It is a demodulator for the frequency FM signal. So that's why it is used in FM receivers. Yes, frequency demodulation. Very good. Now let's start with this one. This is the digital. कॉलेज में सो जाते थे हैं भाई सौरभ बाइनरी टू ऑक्टल 15 a good correct. So basically, but to convert binary to octal, what we can do directly, don't go for the, this is 1 here, this is 0 0. So make a group of 3 here, make a group of 3 here, this is 1 and this is 5. So 15 is directly you can convert from binary to octal, just making a group of 3. Yes, you have to make the group like, first you have to make a group of 3 from the left side, then you can go for the group of next 3. And you have to, if there is no there is you can say less number of bit, you can increase the number of bit by adding the zeros there. FF in hexadecimal is has equivalent in decimal number system. 255. Correct. Correct. It's easy. 255. Got it. So just do one thing. F means 15 into 16 to the power 0 plus 15 into 16. So that will give you 255. 4-bit gray code corresponding to binary code is this. What is the gray code? Yes, what is the gray code for this one? D. Okay. 0010. Good. So for the gray code, what you have to do? 00110 as it is, then XOR of this one, that will give you 0. XOR of this one, that will give you 1. XOR of this one, that will give you 0. So that is 0010. The answer is T. XOR operation. Good. Live of computer science, I don't have about idea about that one, right? About the computer science. He says that binary 0 and 1 correspond to what? They are two different DC level. And what was that? That will be maybe positive for 0, negative for 1, positive for 1, negative for 0. It will be depending which type of logic you are using, positive logic or negative logic. Accordingly we can decide, but what we can say, we are having, they are having two different DC voltages. Just plus 5 or minus 5, that will be depending on which logic you are using, positive logic, negative logic. If you are using positive logic, then one will be represented plus 5 volt, 0 will be represented by either 0 volt or minus 5 volt, right? But if you are using negative logic, then it will be represented by 0 volt and that will be represented by minus 5 volt. Understood? Okay. Do it. One hexadecimal digit is sometime refers to what? Nibble. Very good. That's called nibble. Yes. Answer is P. The best representation of negative number is what? The best representation of negative number is what? Elon Musk, C, A. Ajay Kumar, A. Sign magnitude. That's not correct. Hertz, B. One's complement, that's also not correct. One's complement is not a best representation. Why? In the one's complement representation, you are having two representations for 0, plus 0 and minus 0, that are not practically feasible. You are not having minus 0 and plus 0. You are having only single 0. That's why we are not using one's complement. And sign magnitude representation is also not used, because that is also have two representation for 0. That's why we are going for two's complement representation. That is the advantage of two's complement representation, that is having single 0 representation. There is only one 0. That's why its range is going from 2 minus 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. So what will be the best? That will be two's complement form. Right, Gupta ji? Not B. The answer is C. Answer is C. One's complement is not used. Best way. Inside your computer, currently we are using this two's complement representation to perform any arithmetic operation, plus, minus, and everything. Right? We are not using one's complement. One's complement has two representation for 0, plus 0 and minus 0, which is not practically feasible. Practically, we are having only one 0. Have you seen 0, minus 0, and plus 0 somewhere? No. That's why. The answer is two's complement form. Okay. If you take, yes, CMFT is very good, a very important subject for this exam. Yes, 2's complement 2 times, then you will get what? The original number back. Same number, good. Same number. Hexadecimal number A0 has the decimal value. hexadecimal has a A0 value. It's easy. 160. A is 10 into 16. 0 into 16 to the power 0 is going to be 160. Yes, BCD code is what? Binary coded decimal. It is error detecting code, error correcting code, or what? Both A and B? None of these. Yes, what is the answer for this one? That is D. It is neither error correcting code nor error detecting code. BCD is just a binary coded decimal. It will represent the decimal number into binary numbers. And the last question. Which of the following is a self-complementary code? Which of the following is a self-complementary code? The self-complementary code is access3 code. Access3 code is self-complementary code. So answer is B. कौन सा क्वेश्चन मिस किया भाई आपने 98? लो भाई देख लो, वापस देख लो. See it again. That is just a conversion of A0. Correct? So I think hopefully everyone enjoyed this session, and best of luck from our side for your exam, right? पैनल पे अपलोड हो जाएगी भाई पीडीएफ इसकी, राइट? वी विल अपलोड द पीडीएफ ऑन द पैनल. यू कैन एक्सेस फ्रॉम देयर. So basically, I'm again saying you can join the group, free WhatsApp group, whose link is available in the description. From where we will you can put your questions from your exam, and we will try to analyze that one and give you the feedback that paper is easy or not, and everything. We will provide you the solution here also in the live session, right? Okay, then best of luck from our side. लिंक की बट सर लिंक आ जाएगा, अभी मैं बोल देता हूँ, अभी डाल दिया जाएगा लिंक, राइट? ओके देन बेस्ट ऑफ लक फ्रॉम आवर साइड. बाय बाय.